My name is Jamie Larocque, and I'm part of the global training team here with Altium. And today what we're going to be talking about is the collaboration between the ECAD and the MCAD environments. As we all know, for most of us who have had the pleasure of working between both of the environments or working with a mechanical designer, that communication and that bridge can sometimes be a challenge. It can be tough to kind of transfer those files back and forth. We're communicating through email and whatever the case may be. So just by a quick raise of hands, what most of you will know that didn't sit in my last session, I do like to make it pretty interactive. I always say I don't like to hear myself talk for 2 hours straight and nobody say anything. So if no one's talking or responding, I'm just going to start quizzing everyone and just saying stuff to make you guys talk, okay? So just by a quick raise of hands, who here works in both the environments or works with a mechanical or electrical designer where we have to transfer these designs back and forth? Okay, so pretty much everyone. So would you essentially agree that sending these files back and forth, whether it's step, email, making sure you have the right file, that can be a little bit of a pain sometimes. So we're going to be showing today how we can kind of resolve that, and A, what features we have in Altium Designer to do that, and B, what additional products we have that can help you guys with that. So we'll get started. I like to show a couple little pictures first just to kind of give a better visual of the communication that currently exists between the ECAD and MCAD environments. So first, the mechanical designer might look at the board or look at their enclosure and say, okay, well, how am I going to provide a board outline to the electrical designer? Or maybe they already received a board with some layout of some sort, and they essentially are wondering how they're going to get this to fit. And then from there, hopefully they don't actually take a hacksaw to do this, but they're going to make their modifications to the PCB itself. And they're going to make it fit into that enclosure, and maybe they're going to have a couple of instructions for you to follow to make sure that everything goes smoothly. From there, the ECAD designer gets the board back, or they get the original board outline, and they potentially have to redo some layout because the mechanical designer kind of messed it up, or maybe they shouldn't have given them a board that already had layout on it, right? And then from there, what happens is we get buried in emails, we get buried in static file exchanges of step models, of PCB boards themselves, DXFs, whatever the case may be. So the real question really ends up being, how can we have both of these environments working together to essentially have that seamless collaboration between the two environments? So that's what we're going to be looking at today. So just quickly for the agenda, we'll look at some traditional methods of how we can determine board shape and component placement that currently exists within Altium Designer. So without any additional products, what are the capabilities that we have within the tool? Then we're going to look at those features in Altium Designer. We're going to demo them. We're going to look at the pros and cons and so on. From there, we're going to look at a product that's called the MCAD CoDesigner, essentially what it's going to be and why it's going to be important. So this is going to be the tool that's going to be the bidirectional collaboration bridge between the ECAD and the MCAD realms. We're going to then demo it, and I want to share a personal experience with you where I didn't have the chance to take advantage of this tool because this tool did not exist whenever I was designing myself, and kind of show you the pros and cons of how I went about designing some of these boards and making sure that they actually fit into the enclosures. And there's going to be a good thing and a bad thing about that portion. The good thing is that you're going to learn from me, and the bad thing is that you're going to realize how much I did not know early in my career, and I'm not afraid to admit that. And I'm going to show you why the MCAD designer is going to be important for you in that regard. So first, when we look at traditional methods of configuring board shapes within Altium Designer, who here uses the import DXF option? Is that probably one of the most common ones that we see? You kind of just get the DXF from the MCAD designer, and you go about your business, and you're usually pretty good. From there, there's obviously going to be maybe some changes to the enclosure. Maybe there's going to be specific locations for mounting holes if they have not included that in the DXF either. So you're still going to have some verbal communication or by email and exchanging files to make sure that you guys get that right. Another thing that I've actually done, because we didn't have a mechanical person on staff nor we worked with a consultant to do some of the design for the housing, and then we did the plastic injection molding, but we didn't have a license of a mechanical tool, so it was kind of up to me to kind of just hope for the best. So what I actually did is I would take, let's consider a Hammond enclosure, something right off the shelf. I would order it, I would look at the inside, and I would just take measurements and pretty much hope it would fit. Not necessarily the most efficient way to do things, but it was obviously the way, it was all I had. From there, to make sure that my measurements were correct, I would actually print a 1-to-1 PCB print and take a pair of scissors and cut out the piece of paper and pretty much throw it in here and be like, okay, does this kind of fit? Or are my mounting holes mounting up with my screw bosses, right? So those are some of the traditional methods that we see if you don't have a mechanical designer or if you don't have the proper tools that are going to help you do that. But now this definitely comes with some concerns. The concerns are we're spending a lot of time at our computer back and forth with emails. You kind of hope that you have some type of maybe Google Doc or Google Drive that you're sharing to kind of share some instructions back and forth. Because if you're exchanging files, it's only a matter of time before you pick the wrong file. Next thing you know, your board shape's all messed up, and you might get a little talk from your boss saying, you cost us a little bit of money, when you could have told him or her that, hey, if you just would have bought the tool, we could have saved ourselves from this. Additional to that is that there's no tracking of changes. Unless you're going to rummage through all of those emails or whatever document you had, if something was designed 6 months ago and you've made multiple revisions on it, version control is only going to get you so far. How are you going to keep track of all the changes that are going through for your board shape, component placement, and so on? There's also no collaboration between ECAD and MCAD as it stands right now. If your mechanical designer is external to your company, even if he's internal to your company, how are you guys sharing those files? I think that's a big thing because once again, you're just sending them back and forth. They're going to tell you, hey, it's good to go, and you're going to say, hey, we missed something. So there's no collaboration, which then could result in a possible board respin or increased cost because we didn't put some components in the right place. So first thing we're going to look at is we're going to configure the board shape in Altium Designer. Some of you are going to be very familiar with some of these methods, especially with the DXF, but I want to bring up the pros and cons of using these traditional methods because it's not foolproof. Right? We'll then create a board outline from a 3D body. So bringing that 3D body directly into Altium Designer, and how can we create a board shape from there. And then we're going to look at some component clearance in 3D just to see if our component placement makes sense with what we're working with right now. So it's not meant to be a death by PowerPoint presentation. We're going to jump right into it and look at what's possible inside of Altium Designer. So I'm just going to take a I forgot to duplicate it, just 1 second. So I'm just going to take a standard PCB document and we're going to be looking at a DXF import first and kind of what that looks like from the mechanical side and bring that over on the ECAD side. So here I'm going to work with a very basic enclosure. It's very similar to what I have here. It's a typical off-the-shelf enclosure, nothing really special to it. So what your mechanical designer would do is they would take whatever assembly, whatever you're working with, and they're going to establish, or you're going to tell them, hey, where is this board essentially going to sit? And just by looking at this, there's no screw bosses, there's no mounting holes in here right now. So we can just assume that the board is going to sit on the bottom of this enclosure for now. So what they'll do is they'll select this face, and depending on which mechanical tool they're using, they're going to export to DXF. And then they're going to go ahead, save that, and you're going to get a preview of what it looks like. This looks pretty good to me. There's nothing special that I think we need to do with this right now. I think overall it's a really good starting point. It'll give us our proper measurements. It's going to take the corners into effect. It's going to be pretty good. So we'll go ahead and we'll save that, and we'll see what that looks like in Altium Designer. So pretty traditional way of doing things. We go to import DXF, and we're going to go and find that file that we just exported, and I just saved it to the wrong spot, so let me go ahead and do that again. I'm just like all of you. We all put on the same pair of pants at the end of the day. Mine just might be a little bit tighter some days more than others. but we all make mistakes, and I'm not afraid to admit that. So perfect, it's saved in SolidWorks files. Awesome. So we're going to look at that import DXF, and we're going to pull up this DXF. And then we're going to be prompted with the import options of, do we want to scale it? Where do we want to bring it in as far as the origin? I don't know. In this particular scenario, I wouldn't know what the mechanical designer did. I would just be getting the DXF. That's all I really care about, and I would be bringing that in. We'll bring it in on the mechanical 1 layer. Pretty standard. Shouldn't really have to change anything. It's just going to tell us that the origin is a little bit offset from what we see in the mechanical tool. That's fine, no problem. Perfect. So it's going to create our primitives, and we're going to have this nice board outline. And then right from here, we can go design, board shape, and define from selected objects. We're pretty much ready to rock, right? So now it would be good to be placing some components and essentially start doing my layout. So I'll go ahead and just place a capacitor on here. Listen, for those of you that don't know, I am Canadian, so I work in the metric system. But this still doesn't look right. But you're not going to know this because you're not going to be communicating with your mechanical designer if it was brought out in imperial or in metric. So I don't know if it's in mils or if it's in millimeters. So that's your first challenge right there, is that whenever you're importing this and you start placing that component, you're going to wonder how that person got their job. Right? I don't think any enclosure is roughly the size of a 0603 capacitor. If it is, it's probably not the business for you, right? So that's our first challenge. So this means that when we're doing this import, we would still need to be communicating with our mechanical designer that we need to know if it's an imperial or metric. So if I would have paid attention instead of just assuming, I know that my enclosure would not be 1.5 millimeters by 1 millimeter. So right there, we know that we have to communicate with our mechanical designer what units we're working with. So when I bring this in, by the way, for those of you who didn't realize that, that was on purpose. That was not a mistake, okay? At least that's what I'm going to tell myself anyways. So we see that this looks a little bit better. Let's go ahead and create this board shape again. Let's place this capacitor. All right, now we're working with something a little bit more realistic, we'll put it that way, right? So once again, that DXF import is probably one of the most common things that we see as far as getting that board shape from our mechanical designer. From the ECAD side of things, my personal preference is that I don't like doing things twice. I'm going to share with you a personal experience later on with one of these projects as well. Redoing a lot of layout with tracks, moving components, as I assume most of you know, very, very, very tedious and time consuming. With such a high dense board, sometimes there's not even room to move everything around, and it could be up to a couple days cleanup. So that's essentially what we're trying to avoid with some of the tools in Altium and when looking at the MCAD CoDesigner. So, yes, sir?
When you export from SolidWorks, what settings do you use to generate the DXF file?
So, as a disclaimer, I'm not a mechanical designer. They're going to bring in whatever they think they seem fit. Now, one of the issues, even what I did with the SolidWorks, exporting the DXF from SolidWorks, is I didn't take into consideration manufacturing tolerances.
And that's not what I'm after. The problem is when I have a lot of DXF files is we're using very organic shapes.
Okay.
Splines, Bezier curves, whatever, Altium can't handle that.
Right.
Anything that's not a straight line on an arc, it just blows up.
Yeah, and even if it is going to bring it in, it's going to bring it in on a couple hundred primitives, as we see on some arcs, and that's kind of like your best case scenario. So that would be something to discuss with the mechanical side of things, of how they can simplify that. That's a little bit outside of what we're looking at on the ECAD side, but it's something on the mechanical side that needs to have a discussion because, like you said, it doesn't like the splines. Anything that's not a generic curve or a line, it's going to give us a little bit of trouble.
If you're doing flex boards,
so from the mechanical side of things, that's something that they would need to figure out. So very traditional way of doing it, DXF import, The other traditional method we see using Altium Designer is that we can actually bring the 3D body directly into Altium, and we can define our board shape from that. Is there anybody currently doing that? Or, okay, there's a few people that are doing that, but for the most part, you just get the DXF and you just run with it, right? Okay, perfect. So in the scenario where I have that step model or the 3D model from the Mechanical Designer, I can bring that directly into Altium. So I can go ahead, we'll grab a 3D body, and we'll bring that directly into Altium. For those of you who have been long-term Altium users, you may find this JTAG adapter enclosure kind of nostalgic. And I specifically wanted to use it for that reason because it's kind of something to kind of laugh about. And I knew that most people would kind of know exactly what it was. So I'm going to make it just a little bit lighter just because I don't really like the dark gray too much. So assuming that we're going to get this model from the MCAD designer, and what they would essentially need to do is almost create the board outline for us as an assembly, because I won't be able to just, based on the complexity of this enclosure itself, and I'll show you in 1 second. If I go ahead and I hide that top half, if this PCB assembly was not here, I wouldn't have been able to select where I want that board to sit. You could work with snap guides, you could work with reference points, but if we don't want to get into all of that, we would need to essentially already have this prelim from our Mechanical Designer. So once again, that still brings some challenges because you're dependent on them. You hope that their tolerances are correct, and you need to tell them your PCB manufacturing tolerances. Because there'll be a tolerance to the enclosure itself, just that's wherever you're buying it from. Plastic injection molding is going to expand and retract. You're going to be out a couple mils sometimes. But with your PCB manufacturer, you need to know their tolerances as well. So this is something you still need to communicate to your Mechanical Designer to ensure that they get right. So what I can do from here is go to board shape, and we will define from 3D body. It's going to first ask us to select the 3D body, and then it's going to ask us to choose the face. So we can see here that I do have the option to choose the PCB assembly because this is a model in our PCB panel that we see there. So in this scenario, I'm selecting the PCB assembly, which would need to be provided to you. We're going to go ahead and just make sure that we're going to keep the default settings, and there we have it. I think we're looking pretty good so far. Once again, I wouldn't know the tolerances, so it's something you still need to communicate. But as far as the DXF, you're not going to run into any really scaling issues or anything like that because it was already mostly done for you. So when we look at that in 2D, we can see that our board shape's looking pretty good. And then from here, what you would do is you would start your layout. Start placing components, start routing, whatever the case may be. What you'll notice too in my components panel, you'll notice that I have all these categories for all of my components. Those are not individual libraries that you see there. We're going to be looking at one of the data management tools that Altium offers, which is incorporated in this MCAD CoDesigner presentation. So we're going to look at the components with Altium Concord Pro. So I'll go ahead, I'll place a few capacitors, and we're going to see if we're going to have any clearance issues. Perfect, I'll place that there. And then maybe I want to grab a connector, something that's maybe just a little bit taller. Something like that should work based on its model. Perfect, so we'll go ahead. This might be something that's near the edge of the board. And let's go ahead. Perfect, let's do something along those lines. So if you have your online DRC enabled, obviously you're going to get the old familiar green everywhere on your board with some of these errors. So let's see what this looks like within 3D. So we can see our capacitors are pretty good. We don't see any violations there, although we are getting a violation with the enclosure and the connector. So not only am I hitting it on the side here, but if I bring up my PCB panel, And if I show this, we'll go 50%. We can kind of dive in here and see exactly kind of where it's hitting, right? So bringing that 3D body into the PCB environment to making that board shape, you can use the 3D clearance detection within Altium Designer. Is anybody taking advantage of the clearance when they bring their 3D? It's pretty standard, right? This is a traditional method that we use within Altium Designer, and this does not require any additional tools. It's pretty standard stuff for the most part. For those of you who don't really use this, then perfect, it's kind of a bonus for you. So those are the traditional methods that we see when using Altium Designer. But it doesn't eliminate any of the email exchanges, the DXF, the manufacturing tolerances, the component placement, cutouts, mounting holes. There's a lot of things to consider. So this is when we look at the MCAD CoDesigner. Just make sure I get back to the proper place. The screen doesn't really like when you go in and out of the PowerPoints. So the MCAD CoDesigner is essentially a plugin that's going to give us the ability to communicate with the mechanical realm and the ECAD realm. Has anyone here heard of the MCAD CoDesigner as of yet? Who here, just by a raise of hands? Because if no one participates, remember, I'm going to quiz you all, and nobody wants that. There's a test afterwards. We might not pass. Okay? I will get to that. Long story short, yes. Yeah. So for those of you who have been working with SolidWorks, there was a product that came out that was a SolidWorks PCB connector. This is very similar. It also has a partnership as well. So they do work kind of side by side with SolidWorks. Altium has a partnership with SolidWorks, but it's not limited to SolidWorks. And we're going to look at what other MCAD tools are supported as well.
How come you can't just create a step file from the I've done this from Altium. I created a 3D step file.
Okay.
And you can import that into SolidWorks very easily, and you get the 3D model of everything.
Yeah.
So it depends on who you're dealing with. You seem to be pissing on the MCAD designer.
It wasn't my intention, I promise.
You're assuming there's no communication, no collaboration. Come on.
But you still have to import and export, right? It's still file-based. So it's if I were to put kind of a blanket over everything, we're focusing on the back and forth and the communication more than we are the inabilities or capabilities of each tool. We're working about the collaboration, and that's what the main focus is with the MCAD CoDesigner. So what is it? It's a plugin that gives us the intelligent collaboration between ECAD and MCAD. So as previously stated, we currently don't have that availability to essentially just send it over without it being an import or an export. It's going to allow us to configure the board shape. It's going to allow us to move components within the mechanical realm as well too. So if your mechanical designer notices that there's a component that's hitting the side of the board, he or she does not have to tell you to move it. You can go ahead, the mechanical designer can move it themselves. So that's kind of a benefit as well too, that you're going to minimize that back and forth. Not only can you work both ways and essentially have all the capabilities in both tools, but there's going to be a dedicated panel in MCAD and in ECAD where it's going to track all the changes, who made the changes, and the timestamp of each change. So that's going to eliminate your emails. Not completely, because they're still going to bug you a little bit back and forth. So what does this mean for those of you who could benefit from this? It means that we have seamless, real-time, bidirectional collaboration, no importing, no exporting. It's increased efficiency, and now you can get your board shape right the first time. So what are we going to look at with the MCAD tool? First, we're going to create a project and a board outline right from the mechanical realm. The PCB project does not need to be started in Altium. So if instead of waiting on the mechanical designer, they can create the project and send that over to you ASAP, and you can just open that project right in Altium Designer. Second, from the ECAD side, we're going to place our components, we're going to do our board layout, and we're going to send the components over to the mechanical realm as well. From there, if the ECAD person put some components in the wrong spot, maybe they're now ready to configure some mounting holes, we can go ahead and do that in the mechanical realm. So the functionality from the mechanical side is what's going to kind of give us the edge on efficiency on things that we don't have within the MCAD, in the ECAD realm, sorry. From there, we're going to look at how we manage these projects, how we have the data management between these two tools with Altium Concord Pro. Just by a raise of hands, who here has, I'll get your question. Has anyone here heard of Altium Concord Pro? Maybe you've got an email, maybe John Watson is on the end there doing a conversation about it as well. If you do get a chance, maybe attend some of his sessions or pick his brain on it. He's super knowledgeable in the data management realm. Questions, sorry?
Does this go the same with Nexus?
Yes. Yeah. So I have a specific slide for the licensing afterwards, so I'll kind of explain how it works. But yeah, it's already built into Nexus as well. Okay, so that being said, let's go ahead and look at what we can do from the mechanical side as far as starting the project and configuring the board shape. Let's go ahead and we can close this part for now. So once again, we're working with the same assembly. Instead of taking the same approach with the DXF for the manufacturing tolerances, we're going to go ahead and start the project within the MCAD realm. We can see here that we have a dedicated, you can't see that because I did not duplicate my screen. I could have rambled on for the next half hour and you wouldn't have seen anything. Perfect. So we have the dedicated Altium CoDesigner panel. So we're going to have two options here. We can pull an existing board that already exists within Altium Designer, or we can go ahead and start a new project. In this scenario, I want to start a new board assembly because in my eyes, it makes more sense that before you do the board layout and start placing components, that you have an accurate board shape first. So we can go in here, we'll name it, let's call it MCAD 1, and we'll go ahead and create that project. So what it's going to do is it's going to create a mechanical assembly automatically for you inside of your mechanical tool, in this scenario SolidWorks, and we're essentially going to get a default PCB board that's going to be a mechanical assembly. This is the board that we're going to be using to push back and forth between the ECAD and MCAD realms. So we can see here by default the board is black and it doesn't have the same color of the solder mask green that we see inside of Altium Designer, but that will be updated once we bring everything over from the ECAD side. Yeah?
So what exactly did that do? Did that just create a project on Concord Pro?
Yes.
Did it use any of the templates? Do we have a project template?
No. Yeah. So because the only way I could see it being a template is that if you, the PCB document, but this is more for a board shape than it is anything else.
Well, even in our PCB, well, you can't hold PCB templates yet.
Right.
But we have templates
Yep.
coming with the project, so this just creates a generic with nothing in it, no.
Correct.
No.
Correct. I would have to look into more of the Altium Concord Pro side that if we can get a project template associated, that whenever you open up this project, if the schematic and PCB documents exist, that's what you're saying, project template, right? I would have to dive into it a little bit more, but from the mechanical side as is right now, there's no template being applied. So what we essentially need to do is we need to bring this PCB into our enclosure so we can configure that board shape. So your mechanical designer, he's going to open up this project, he's going to see the PCB, he's then going to insert, he or she is going to insert a component, and in this scenario I have an open document. So I have the board that's opened in SolidWorks. I can simply select that, and we're going to bring that into our enclosure. I'm just going to place the board relatively close. It doesn't have to be perfect because that's not where the board is going to sit. If I were to do that, I'd probably get fired on the spot thinking that this is the right board shape. So what we need to do now is make sure that the board is sitting on the bottom face of the enclosure where we were going to export the DXF. So the mechanical designer could create a mate. So what I'm going to do is I'm going to say that the bottom of this board is going to be mated to the face of this enclosure. I can go ahead, looks pretty good. I'll accept those changes. And let's see kind of what we're working with here. See, I broke the mate already. So we can go ahead and delete this mate. Let's go ahead and rebuild. As you can see, I'm not a mechanical designer, and that's very evident. So what we would do now is we would actually go and we would make a modification to the assembly of the board, or essentially the sketch of the board, so we can change that board shape. So I can come in here and I can edit the sketch. What's kind of cool on the MCAD side is that you can essentially move the board shape around just like you would primitives in Altium Designer. So if we look at these lines that exist right now, for those of you who only work in the ECAD realm, a sketch is essentially what we're working with our board outline. If you want to consider these as our mechanical layer lines, they would go in here and they would make whatever modifications they want to make and then accept those changes. But there is some additional intelligence in the MCAD tool that we don't need to manually configure every line, every arc, everything. We can use, I know in SolidWorks, we can use something that's called offset entities. And what this is going to do is it's going to allow us to select a face, and it's going to take that face and we can essentially create our board outline or our sketch from that face of that enclosure. So the yellow dotted line is what we're going to be working with as far as our board shape. This obviously isn't going to work, so we're going to have a couple options. Maybe I can reverse it, but that's going to be a little bit too small. Maybe I can go to 2 millimeters. That's looking a little better. I might even be able to go to, let's call it 1.5. So one thing to take into consideration here is that you may want to discuss the PCB manufacturing tolerances here, because if you're going to be putting this in a harsh environment, the plastic is going to kind of flex. So we want to make sure that our mechanical designer is giving us the proper space allowed off the enclosure, just to make sure we don't have any fitment issues. So it's going to be up to you, the ECAD designer, to provide the manufacturing tolerances for the fab house you're working with. So we can accept this. We're looking okay right now. And just like whenever you're creating a board shape in Altium, you can't have two enclosed pieces and try and create a board shape from all of those primitives. So we're going to remove the existing sketch. Okay, and then I should be able to rebuild this if I didn't delete something additional by accident. Just make sure I'm removing the proper lines. Okay, we're going to rebuild this model. And there we have our board shape. So I think we're looking okay so far. This is kind of the benefit of having the mechanical tool, where there's a lot of stuff that you can't do in Altium that you can do in here. So this is the main top assembly with the enclosure. But remember that we have a specific assembly for the PCB document itself. So this is the actual assembly that your mechanical designer would use to push back and forth to you. So every change that we made in the top assembly, because they inserted that component, we now have that board shape available, ready for us to push over to the ECAD designer. In our dedicated panel, it's going to show the name of the project. I named it MCAD 1, and it's going to show its activity. So I'm going to hit the push button. This means I'm sending it to the electrical designer, and I'm going to say that we configured the initial board shape. Whenever I go ahead and post that comment, you'll see here that we're going to have the name of the author. Right now, through Altium Concord Pro, I'm signed in as the administrator. This can be your name. It can be whoever is making that change. You're then going to see the comment that was also added to that specific change, and we have the timestamp of when it was done. So now we're ready to go back into Altium. We're going to go ahead and close this, because that PCB is no longer relevant for us. And we're going to go ahead and open that project. We might get an email, and we're going to say, your board shape's ready to go. Go ahead and do the board layout. We're going to open the project. We're going to look at what the back end looks like of Altium Concord Pro later on. And we can see here that we have the MCAD 1 project already readily available to us. So let's go ahead and open that up. And like you said, I would just have to expand on the project templates just to make sure if that's possible. And we'll go ahead and we'll add a PCB document. So once again, it's not going to bring in the board shape that we just configured because we haven't pulled in any changes yet. It's still going to give us the default PCB as you would see at any other time. So in the Panels button, we have a dedicated MCAD CoDesigner panel. And I'll probably have to sign in and sign back out. And it's not liking it very much. And obviously when you have demos, it never really goes as you anticipate on it going. So let's see what we did from the mechanical realm. We pushed it, we're signed in, use custom server. Perfect. Let's do another push and let's see if it gives us any changes. Signed in through Concord Pro. It would be too much to ask if everything went right. Well, it's not really liking me right now. So what I'm going to do is we're going to restart and we're going to close Altium. Have any of you heard of the Altium 365 yet? Is anybody kind of privy to that product? Has heard anything about it? No? So we're going to be seeing some of that later today. This functionality is available in that as well. And it's kind of a new product for Altium Designer. And I'll go ahead and close this. Close that, and we're good. Maybe I'm the one that's going to be falling asleep and not you guys. Yeah, probably. And then smash it a couple times, and then it should work, right? So I just want to lure you guys in. I get lonely sometimes. I just want to have a conversation for 2 hours, and that's pretty much it. We didn't come here to do important stuff. That's not what we came here for. From the mechanical side of things, we do support 3 mechanical tools, SolidWorks being one of them, Creo being the other from PTC, and Inventor. For the most part, those of you who are doing collaboration, who here is using SolidWorks? For the most part, okay, and Creo? Awesome. Anything from Inventor? Process of elimination, okay, cool. All right, so let's see if it likes us this time.
Any other tools in the works?
Pardon me?
Any other mechanical tools in the works?
So that's something that we were discussing earlier. We actually do have someone in the crowd today who's the product development for this product. His name is Nikolai Nirkov. He's this gentleman right here. So anything about future developments, if you guys have any questions, he would be the person that would have the best insight to that. And so anything as far as that, like especially from a data management, component management, we're looking at doing a lot of development on that side of things.
I mean, we are CATIA based.
Yeah.
Anything in the works there?
That's the plan.
I don't want to steer you down the wrong path and also tell you something that may not be accurate. But yeah, so there is strong development going on for it. We do have a lot going on as well. We're getting a lot of feedback from different people internally and externally as well. So it's been pretty good. But as far as the CATIA, I know it's a pretty popular mechanical tool as well. All right. Let's see. I do have a backup for you guys just in case this doesn't seem to work. Perfect. I also did a complete reinstall and uninstall maybe 3 days ago. I probably shouldn't have touched anything because we all know how that goes. So we would have the dedicated MCAD CoDesigner panel that's available within Altium Designer. So we can see here, whenever I bring that up, we see the changes that were made from the mechanical side of things. We see who made the changes, what are the changes, and we can view those changes as well. So when you hit View Changes, we can see exactly what was done. So in this scenario, all we did was configure the board shape. It's going to be the only option available to us. When you click on it, you're going to get a preview of that change as well. So you can choose to accept or decline those changes. So in this scenario, we know that's exactly what our need. Our MCAD designer gave us a nice board outline, and we're now ready to rock. So in this scenario, ready to do layout, ready to place components. Well, I saved you guys, since I wasted about a good 4.5 minutes restarting everything, I won't put you through the trouble of placing and routing a bunch of components. Who here has heard of or is currently using snippets or has used snippets? Okay, a few people. So this will be something I can briefly talk about for 30 seconds as well. So a snippet is where you can essentially grab a piece of circuitry. It could be on the schematic or on the PCB side, and you can save that out for reuse. So a lot of times people might just have circuitry on a schematic, add that existing schematic to a new project, and then just delete or change whatever they don't need. But from the snippet perspective, for schematic and PCB, we can go ahead and reuse this circuitry in any of our designs. So what I did is I saved all the circuitry from another project to save us some time, and I can go ahead and place that in here. I want to make sure that I have these pins kind of going off the side of the board because I want to show you the pins that are going to be popping out of the enclosure later. So something along these lines should be good. And then we're going to get the good old nice green DRC that we just love seeing all the time. And we're going to turn that off. No one wants to see that. The thing with the snippets is that whenever you bring it in, it doesn't take in all of the routed net information that you used from another project. So if you had C1_1 going to a specific capacitor, it's not going to have that information. You would have to link that with your schematic later on. So we can see that we have some 3D bodies, we have some through-hole components, we have some surface mount devices. I think this is kind of a good representation of a board that we can use to demo this. So assuming we laid this all out in a matter of 15 seconds, because that's how much of experts all of you are in routing and placing components, we can push this back over to the mechanical person and say, you know, let me know if there's any changes, if there's anything additional that we need to add. Here's my final product, or here's a halfway through the product. Let me know what you think. So we can write that we added components and layout. Perfect. So we'll go ahead, we'll save that PCB to this project. And it's always going to take a little bit of time on that initial push and pull because I'm going to explain how it does the translation of the files from ECAD to MCAD.
What did you just say right now?
Sorry, what portion? I said it was just going to take a little while to push it over. It was just the PCB document because I just added a new PCB document. So I brought the project in, and from the mechanical side, it won't create a PCB document for you. Yeah, so I just had to add the doc, and I just saved the document. Yeah. I thought I said something I wasn't supposed to say. I thought you were testing me there. I was about to leave. I was going to leave the class. I'll be like, all right, thanks. I'll see you guys later.
So you have to have this window open to get notified.
Yes.
Close it down a lot, and I have a problem with Nexus, like not saving where my windows are, so when I open up, it's not there anymore.
Yeah.
If I forget to start, if I don't have this window open, and I've made a bunch of changes.
Unfortunately, yes. Yeah. So, I know. Once again, good thing Nikolai is here, where you can redirect those questions. Just deflection, deflection, deflection. No, but I completely understand, and I was on the support side before joining Altium. I worked for a reseller that handled Altium across Canada, and it seems like a very trivial thing that can be implemented, but it would be a lifesaver. So as far as the implementing of that and those capabilities, I want to save some time afterwards so you guys can talk to Nikolai. He had a long flight over. He's from overseas, and it's been a big, big benefit having him here. So I encourage you all to discuss anything that you guys need or concerned about, especially from the Nexus and Altium Concord Pro side of things, right? Because that's a functionality that is already existing within that tool. So I highly encourage you to discuss with Nikolai after this. So we added our components, and we can go into the SolidWorks realm. And I had to restart it. So let's say if you close the software and you know it's another day, whatever the case may be, we can pull this project from the server. and it's going to go ahead and save out this solid assembly. So what it's going to do, it's going to take all the 3D models from the ECAD side of things, and it's going to translate them all into the native file format of what your mechanical tool is. So in this scenario, SolidWorks uses solid parts, so it's going to bring in the 3D bodies as solid parts into the mechanical realm. So on that first initial push and pull that we see from ECAD to MCAD, this process, depending on the complexity of your board, could take a little bit of time. It's going to bring in the copper, it's going to bring in the components, and so on and so forth. So if you have a really, really, really dense board, go make yourself a coffee and come back and it should be good. So here we have everything that's brought in. We have the timestamps of all of our changes. You can see on the feature tree here with all the models, we have the designators of every single component as well. So we're going to look at our top assembly. And in this scenario, I'm likely going to have to do the mate once again. So we can insert, because once again, it just thought that it would challenge me today just because. Okay. Perfect. And in this scenario, because I screwed it up from the start, it would have had that proper mate, so that's why I had to move it over. That is my fault. So what we can see here is that we're looking with something that's pretty accurate. We don't really see any components hitting the side of the board other than these 6 tridents that are going right through the enclosure. That's not going to fly. So your mechanical designer is going to have to make some changes, and he's going to have to fix your mistakes. So what can they do? Let's start by making a cutout to this particular enclosure, and I'll make sure that everything is rebuilt. Perfect. So for the pins, let's go ahead and we'll make an edit to the enclosure, and we're going to edit this part. And then we're going to start maybe just making some rectangles just to cut out these components. From the ECAD side of thing, it's not super important because you won't really see the enclosure, but the mechanical designer is going to hook you up and make sure that everything is good to go. So we'll sketch, select this face, and we'll do some rectangular cutouts. Perfect. Let's go ahead and end that command. And what they would do is they would essentially cut these out. So we can see here kind of what we're working with. Going up to next might work. If not, blind will be okay. So this looks good. They're going to look at it and say, hey, is this going to look good to cut out the enclosure? Okay, so I don't think I'm going to have any issues other than just on the bottom of the board. If you have some mounting holes or screw bosses, whatever the case may be, they would have just mated that board to the top of the screw boss, right? So they would have done that properly for us. Once again, we're not too concerned on the ECAD side. We're just more concerned on the MCAD side. From there, maybe we do want to add mounting holes. In this particular scenario, there is no screw bosses, but I want to show the functionality that we can add mounting holes from the mechanical side, and it doesn't have to be done in the ECAD side. So we can go ahead and we can make an edit to the board outline, edit this part. We will go ahead, just like in Altium, the sketch in the mechanical realm is just as if you were to draw a circle. You open up that circle, and if you want to create a cutout from that circle, that's exactly the same thing from the mechanical side. So I'm trying to just kind of reference it from the ECAD side of things of how we can relate between the two tools. Perfect. Let's go ahead, make some holes. Doesn't really matter where they're placed right now. I'll go ahead and I'll smart dimension them, so I'll make sure that they're both the same size. 2.5 should be okay, and we'll do the same thing here. Perfect. And I forgot to extrude the cut, so once again, made another mistake. So let's go ahead and change that. And it's sketch. There we go. Just like we did with the cutout of the pins, we will go up to, might be able to do through all. Let's see what options we can have here and reverse the direction. Up to surface. No, let's just do blind reverse. Cool. All right, well, I think it made me a liar once again. I'm going to redo that. We will remove all of this. Make an edit to that part, and we'll sketch once again. It's funny because at the start of the presentation, I was just saying that I don't like to do things twice and over again, and look at me redoing it 6 times over.
Oh, you're not doing it twice.
Yeah, you're right, because I never did it in the first place. That's a good point. I respect that. Okay, so obviously I'm having some issues in the mechanical realm. I'll show it within the ECAD realm. I promise you it's not a limitation to the tool. I've done it 100 times. Just for your sake for today, we'll cross that bridge. So we haven't done any other changes other than the cutouts to the enclosure. Maybe we want to move a component. Maybe we want to move this resistor. We'll just move it up a little bit. Make sure that everything is rebuilt. Perfect. Let's go ahead, edit that assembly. And I can select components and I can move these. So if we're having any clearance issues, we can go ahead and move those components as well.
So at this point, if I remember correctly, you've already, this is an already laid out board.
Correct.
So you just moved a component off of this trace.
Correct.
Okay.
Yeah. So what you'll notice, and we'll talk about this a little bit more, you see that I moved the component, but the copper pad stayed behind, right? So right now, the copper, the way I have it set up, it's just as a decal. It's essentially just a picture. So there's no real intelligence to it right now. So if and when we do a push and pull back into the mechanical realm, that copper will be updated, but we will see the component right now that's going to be moved in ECAD. So it gives the MCAD designer the ability to move components. You can lock them. If you don't want them touching anything and you said, please let me know before, or if they say, listen, the ECAD designer, you're way out to lunch. This shouldn't be here, so I'm going to do your job for you. They can do that as well. So there still has to be some boundaries and communication between the two people, but the capabilities between the two tools are there.
You still have the ability to accept their changes, right? So you could basically
Sure.
not accept their
Sure, you can just say like, you know, no thank you,
Right.
in a very nice way.
Thanks. Okay.
Yeah. So in this scenario, what had happened when I screwed it up is that I made a change to the board and not to the assembly itself. So that's why we see these issues right here. I might even be able to just delete them completely. Let's see what I can do here. Yeah. Yeah. Yeah, that's good for now. I'll just show the mounting holes actually through the ECAD side of things. And that way there you guys will understand that it's still possible. So let's go ahead and push. We're going to say cutout for enclosure and moved R3 because we know that R3 is that component. We can go ahead and accept those changes. Perfect. Go into Altium, pull in the changes. We can see now that we get a preview of R3 being moved over. I think we can do the preview in 3D as well if preferred. I already did the preview, so there you go. You can see it in 3D. For the cutouts, obviously it's not going to show as we want it to, but it does show these gray circles. If I would have done my job properly, you would have been able to see some holes there. So we know everything looks good. There's nothing really out of the ordinary that's going to mess up our layout. So let's just go ahead and accept these changes. And there you go. The holes magically came through anyways, so I did do it twice. Okay, so we have the ability to do it in the mechanical side as well. So from here, maybe we want to, in this scenario, I would have to redo some tracks. It's not going to bring the tracks, but you're going to hope that you did it right in the first place to begin with. You're going to hope nothing is kind of too far off, that the cleanup is going to be minimal versus if you were to just give them the layout from the start.
So you started project SolidWorks.
Yep.
So did that immediately make it a managed project?
Yes.
But that's only through Concord.
Correct.
What about if you don't have that?
There is, from a licensing perspective, it's not meant to be used in any other way. So to get this functionality, in which I'm going to show from the licensing perspective, you would need Altium Concord Pro or Nexus to do this. So in this scenario, you would need to purchase that item. So for Altium Concord Pro, you also get the project management. So in this scenario for MCAD, instead of I'll just jump to it right now versus later on, Altium Concord Pro is being used as a communication and collaboration method between the two environments. For this particular feature of Concord Pro, although it's not the only feature, it's just a feature. Concord Pro, it's its own data management platform. From the MCAD side of things, it's meant to collaborate and communicate. Yeah. And this applies for Nexus as well. Yeah.
Do you have an example of doing this with a flex board?
No.
So when you push this from the mechanical side back to my flex rigid where I have different layer stacks defined, is it going to pull all the layer stacks up?
Just wanted to mention that AX65 is supported as well.
Okay, for rigid flex?
Well,
That's okay, instead of getting,
it's supported now in SolidWorks PCB solution.
okay,
And going to be supported very soon in our own solution for AX65, for Pro and Nexus. I can show you a beta version of Rigid support and can explain how it works and how mechanical engineer can change, for example, the shape of Rigid board and so on and so on. So just don't hesitate to indicate.
yeah.
After.
So that particular topic, I'll just have you take it offline with him.
Yeah, because there's a bug already where whenever you change it and update your layer changes. I didn't know if they had it.
No, there's no bugs in any of the tools we have. Not one. Not one. Listen,
Unintended feature.
we're all doing the same thing, right? And it's not my job to be here to be salesy, to hide anything from you guys. That's not the point, right? And I think one thing, I know you guys just met me a couple hours ago and we weren't off to a good start, but I wouldn't lie to you. And that's why I said here, we're here to demonstrate the functionality, but I will never deny that there are some things to work on. So we do have a dedicated blocked off session for some development actually this month that's headed by Nikolai as well. So we're going to be pedal to the metal, vice versa, pedal to the metal. So with developing the tool, okay? So everything looks okay so far other than a couple routes that I would just have to clean up. But what we've noticed inside of the PCB here is that you can't see it right now, but it only brought in the top and the bottom layer. It didn't bring in any of the mid layers. So we have some functionality inside of SolidWorks where we can enable some modeled copper. And the benefit to this is two things. One, whenever you bring the modeled copper in, you can see all the inner layers. So if you have copper layers that are going through board cutouts, if you have copper that's going through a mounting hole, if you have a screw and you don't want the head of the screw to be touching the copper, the mechanical designer would be able to see the copper inside of this board right here if I change that transparency. So we can see that. Another thing from the ECAD side that's good is when you start the project in the mechanical realm, it doesn't know the thickness of the board, right? It doesn't take the layer stack information into consideration. One of the items I didn't specifically mention is that the board outline was a preview option when I pushed it back to MCAD. So as soon as you go ECAD to MCAD, it brings in that board thickness as well from the layer stack. So it's going to give you an exact representation and size of that PCB as well. The only reason why it didn't show it at the start is because I started it in MCAD. So that modeled copper, yeah, sorry, go ahead.
Can you edit the copper inside SolidWorks?
As far as I'm concerned right now, and maybe Nikolai can chime in, I haven't found a good or accurate way of moving any traces or anything within the mechanical side.
I'm not interested in moving traces. For example, for when I'm making a embedded transformer. Those things are more easily done in a mechanical tool than they are in Altium. So to make a spiral track or a special shape where a ferrite core can clamp around, doing that design in MCAD, pushing it into the board as copper structure.
Right.
That's an interesting point, by the way, yeah, not supported for now.
Not supported as of right now.
For now, yes, we are thinking about it. For now, we can only transfer copper and some extruded bodies from ECAT to MCAD. Just in order if you want to do some check, for example, for multiple, if you have a quite dense layout of your device and what you need to make actually a micro-precise design of your device. So you need to know the exact thickness of the cover. Plus, thermal analysis, for example. So it's also possible. And now we can transfer that copper. But please keep in mind that, to be honest, it takes a while. So building copper takes a while. So we are suggesting to do that only if you really need that. Otherwise, saving or applying just a feature with copper, as you can see now. Now it's just a feature, which is representing copper. It is enough for most of the cases. Yes.
Yeah, but if you have, if you're trying to make a planar transformer in the board, those are very complex polygons, and it's not really easy to design those things in Altium. So it would be really good if you could do it. Or for example, you're making a radar antenna.
Yeah,
I think to do a DXF, just import the
Yeah, but the
DXF.
problem then that comes back to my original question. It can't handle B-splines, it can't handle Z-curves, and I'm having all kinds of problems. I'm doing 76 gigahertz radar board. It needs to be correct, not an approximation. Or my antenna will not work.
You're right. Well, that's what you're trying to do.
So that's maybe something that we can get some more feedback from you as well too, directly to Nikolai. So we'll, when Nikolai first came in, he was kind of like, there's one thing I ask for you. He's like, make sure you get feedback from everyone. And this is exactly what we're doing, because the product itself is not in its infancy, but it's only a couple years old. We've seen it in other forms. It only is a couple years old. So he's been doing a great job heading that, and we are making those improvements, but it's things like this that's going to make it better. So.
On these transfer, radar things, you're not using AWS or?
Yeah, we have a couple of different tools. Yes.
Yeah, but they don't have something directly to the PCBs now? No. You just get the picture, you get the DXF?
Yeah.
Okay.
This is all approximation. So what it has to be able to, either from CATIA or from SolidWorks, they have to bring in the right model and just say, okay, now convert it into a polygon in Altium and be done with it.
Right. Yeah.
Just hope for the best. Just guess. It'll be okay. I'm just kidding. I'll just have, he had a question earlier. My apologies.
Yeah, so the structure that you just pushed in from MCAD, ECAD,
Yep.
cutouts, they exist in the board outline or in the board shape, or how do you get them to be like in the drill file or something?
In the what, sorry? That last part?
The drill file, like the whole, like the mounting ones. How do I get them to be more than just being in the board? Yeah.
Yeah, because they come in as cutouts right now.
Yeah. Is there a way to get them to like translate to something more useful for my export? Like I said, drill file in there.
Nikolai, you don't have to use your hand because I was just going to let you speak anyways. So go ahead.
Yes, we have a special option for that. We will check the settings at SolidWorks side.
On the what, sorry?
So we have a setting which tells which diameter should be kept as a limit for recognizing features as a cutout versus pads, standard pads. So if the size of your feature is bigger than that limit, it would be recognized or taken into consideration as a cutout. Otherwise, it will be just a pad.
So we'll come in as that.
Yeah.
If it's the pattern. Yeah.
Was that similar to your question, or?
No, I was just going to have a counter argument that I don't want mechanical guys touching my electrical traces. So if you put that in there, please don't put it by default.
That conversation doesn't involve me. You know, you also don't want to step on their toes because they're making that board shape for you. So.
But we don't work on 76 gigahertz stuff, the high frequency stuff. They start moving it around and cause problems.
Yeah. I'll worry about getting my mechanical designer a coffee first before he gets me my board shape, and then we'll go from there.
Otherwise, you find your board shape suddenly getting smaller.
Yeah, that first DXF I imported was actually from someone. I think they were trying to teach me a lesson there. So from the mechanical side, we do have the mounting holes. They come over through the ECAD. We do have component placement. Another thing that we're actually, it's in development right now, and I don't want to bug Nikolai right now for it, is that you will soon be able to place components from the MCAD side as well. So in this scenario, we were just showing a common scenario where we don't want to redo the layout, so we started the project from MCAD. But that's something that is under development as well as placing components from MCAD. What I want to share as well, just quickly, is that I'm going to show you from the Altium side to the MCAD side. Because if I was just thinking now, if we want to use that project template, you could start the project in Altium and push it over, and it's not going to be affected. So let's go ahead and close this project for now. Once again, this project is stored in Altium Concord Pro. And we'll go New Project, Concord Pro.
Do any of this with an older vault? Were you still using 3 something vault versus Concord?
I'm going to go out on a wild guess and say that the functionality is not available because I think the way that it came about, as far as some of the product marketing and naming, is that Vault 3.0 went to Nexus Server, and then Nexus Server then became Altium Concord Pro. So that would be something to probably discuss. I'm not sure if Nikolai knows that. It could also be something to discuss with the ACP or Nexus team as well. Is MCAD available in Vault 3.0? Okay, there you go. That's why I didn't give you the wrong answer. I don't lie to you. So there is a,
We're updating shortly.
so there's already a transition roadmap from 3.0 to Nexus Server to ACP. So it could be something to discuss with support as well, or the salesperson that deals with your company. Just say, hey, you know, we're looking to make the transition because there's licensing that needs to be considered as well. They're now, so there you go. But
yeah. It was very odd because we were going to renew the licensing, and then we got the licensing for Concord Pro.
Right. You're like, what's this? You're like, did you give us free licenses?
I had no idea.
They're not that nice. Come on.
No.
No. So there is that licensing issue as well too. So I would recommend that you use the support staff to help you through that because there are certain things that do need to be taken into consideration. Just an FYI.
Anybody in particular?
That's a good question.
One of the issues that we're facing is that we did back to Vault 1 point something,
Okay.
which was an Oracle.
Okay.
And this seems to be an insurmountable problem moving to Nexus and Concord Pro.
Yeah.
We can't get the data out of that.
So we do have the dedicated Nexus deployment team. I'm not sure if you were dealing with them. I can give you some contact info for those people for sure, because they were responsible for moving some people across those platforms. So I will provide you with 2 names that I am aware of, a part of that deployment team, and they can help you out. Okay. So once again, just from the ECAD side, just to kind of show that we can have these components, we can have the board shape. I'll go ahead and place this. Once again, if you're using the project template, this is probably the better way to do it. And you're going to say, please nicely configure board shape. I'll buy you lunch. But it's going to be like McDonald's. It's not going to be anything too extravagant.
So this is just going the other way now.
Correct. I'm showing the exact same thing we showed earlier. I just think it makes more sense to start in MCAD because they can give you a nice board outline and you don't have to redo any of the layout. What if I start putting components in the wrong places? Well, I just wasted my time placing that. So I'm just showing it right now. I'm just showing it the other way. So we can discard all of this because we're starting a whole new project. And we'll close that up. And the good thing about pushing from ECAD first is that you get the board thickness and the green board right away. Pull board from server, MCAD test. It'll create a new board assembly.
Now when you did that, that's all the projects. They're going to see all the projects in our server?
Yes.
Every one of them.
Yep. Which is all, well, I have a project open right now and I'll close it. And I'll actually show you the list of projects. Then we'll jump into the Altium Concord Pro and I'll show you those projects in my Altium Concord Pro, that they're both the same. Okay, so once again, bi-directional. It works from the ECAD side of things as well. Perfect. So just goes to show. So here they would pull board from server. So these are currently all the projects that I have stored in my Altium Concord Pro, which is accessible from the MCAD side and also accessible from the ECAD side. By default, you'll notice with some of the latest revisions of Altium Concord Pro and Nexus, there's some sample data that was installed. So there's 600 components, there's some projects. So those COMI projects is what, you might actually see this Thursday and Friday as well, because they might be doing some demos on that. I could be wrong, but that's some of the sample data. And today I created the 2 projects at the bottom. So if I want to look at this through my data management lens, I can go about accessing the projects 2 ways. One way is if you have Altium Concord Pro or Nexus. If we open up this panel right here, this is where all of our components, projects, templates, anything that you have stored in that data management tool are going to be available in this panel right here. So we can see that if I extend the projects, I have my projects right here. I have all of my components, all of my templates, and everything is readily available for me right here in Altium Concord Pro. So it just goes to show you the projects that are matched in SolidWorks right now are matched up with the projects right here. And if someone doesn't want to tie up a specific license of Altium Designer or whatever the case may be, some of you Nexus folks might have seen the web browser as well, where we can access these projects from the web browser as well. So when we think of the MCAD CoDesigner and we think of it with Altium Concord Pro, it's the collaboration and the communication that's not available with anything else. So,
Can we delete one of those projects?
yep. I don't think the mechanical side can do it, but I could be wrong on that. But yeah, absolutely. If it's just deleting it through Altium Concord Pro, just like you would anything else. I can actually just show you that quickly right now. So if I went into my projects, we'll just access it from the web browser right now. I could just go in here and hit delete. And then next time I open up Altium Concord Pro, that project will no longer be available.
Yeah, like if it fails, you can just upload another one.
Yep. Yep. Especially if you haven't gone too far in your design and maybe if you're already seeing some issues. We obviously knock on wood, hopefully that doesn't happen, but yeah, you can just start it and then just delete the old one.
That's also subject to whatever permissions your world has.
Correct. So for those of you who do not have Altium Concord Pro or Nexus, the good thing about having that data management platform is that you can add and remove users. So let's say the 3 of us work for the same company. Maybe you're the administrator. You have the keys to the city. And maybe I'm just a designer and I'm not allowed to add files to a project. I'm not allowed to do much. All I need to do is just open the project or make changes to something on the PCB. So what the administrator can do is make sure that, hey, since Jamie screwed up the MCAD demonstration and created holes 6 times, I probably shouldn't give him any rights to remove or add any projects. So another level of, let's call it security, is that you can limit what functionalities and what permissions that people have using that tool. Absolutely. Yep.
So on that same note, when the mechanical designer has a window open, is it using a default license?
That's a good portion. Does it use a client access license?
Not for now.
Not for now.
So it doesn't check anyone.
So take advantage of it now.
Yeah, because we have, 5
Yeah.
or 6 guys using it, and if I have 10 mechanical designers that are plugged in, it's a lot of licenses.
Yeah.
I don't have to support it.
Yeah. So as it stands right now, it does not take up that CAL license. But does the web browser take up a CAL? No. Okay. So that's good too. So I don't like to show any demo magic. Of course, all of the licensing, as we kind of already covered, I was going to save it till the end, but we pretty much already covered it. From the ECAD side, you need to have, yes, sir.
So I forgot to mention.
Yeah.
It will be changed in the future.
Yeah. That's always like the disclaimer. That may change. We may ask you for more money, right? So
We reserve the right to change.
we reserve the right. Yes, sir.
Where are you storing the files on the MCAD side?
So that is, and this is always the gray area, and I'm happy you brought it up because we were going to talk about it anyways. Right now, the MCAD CoDesigner's main purpose, collaboration and communication. It doesn't have a dedicated storage method right now for the SolidWorks files. So what happens right now is that all of these solid parts that came from the 3D models from Altium went into SolidWorks, created a solid part. Those parts are stored within the SolidWorks assembly. So they're stored in a folder, they're readily available, they're there. The only thing is that there's no dedicated data management capability right now to to govern that.
SolidWorks has its own data management system.
So at this time right now, MCAD CoDesigner is not compatible with SolidWorks PDM. And this is why we have Nikolai here as well.
I thought the connector is compatible with the
So we'll talk about the connector afterwards because that actually ends up being, the connector is the SolidWorks product. It's not a part of Altium. So go ahead, Nikolai.
Well, I would say it's not. The only side effect is that you will see duplicated parts in your PDM system if you use it. In case you are going to check your parts, check your bill of materials into your PDM system from PCB assembly. Do you understand what I mean? So because we are actually sending our own parts with our own names, and if you have your own models stored or managed by your PDM system, and if you check our assembly into your PDM system, you will see the duplication of parts. This is the side effect. Just once. This is the side effect. But in the future, in the nearest future, we are going to take those native models. If user works with MCAD user works with PDM system or some special kind of storage, we are going to take native parts. If user manage those parts and place those native parts and avoid any duplication and provide a better way to manage your materials.
So essentially that's the reason why we don't advertise it right now, because it doesn't work exactly how we'd want it to. And the same thing goes for Creo and Inventor as well.
It's just a library problem.
Essentially, yeah. Essentially, when you break it, long story short, yeah. Right? So but as Nikolai said, it doesn't mean that it's not going to change in the future. And if you guys stick around and ask him a few more questions, we do have like estimated timelines of when certain things are going to come up. For Creo as well, Nikolai kind of discussed earlier before the presentation as well. So for those of you who are using Creo as well, maybe if that's something that interests you, just talk to Nikolai and he'll kind of give you where the roadmap is for that particular product as well. So from the ECAD side, we kind of mentioned you need Nexus, you need Concord Pro, and it's just an extension that needs to be installed within the extensions and updates. And then from the mechanical side, there's a plugin. So for us, for SolidWorks, it was just the enablement of a plugin. But depending on which mechanical tool you are using, there may be a license agreement in place that you may need to purchase separate licensing through them. It's different for all of the mechanical tools that we support, and just to make sure that you're using it as per the end user license agreement. And we support SolidWorks, PTC Creo, and Inventor. So, personal experience. As I mentioned, the good thing here is that hopefully you're all going to learn from me and be better than me, because I wasted my company time and money, and we just love doing that. The reason is that I didn't have the MCAD CoDesigner tool. So let me tell you a little bit of the process that I took and why I could have benefited from the MCAD CoDesigner. When you look at these projects here, I worked for a company that created products for the mining sector, underground mining. They do proximity systems. They do cap lamps for miners underground, as well as radios, RFID systems, and the whole nine. So as you can see, everything that's pretty much the common denominator in each of these pictures is that they all go into some type of enclosure. So I want to talk specifically about one project, because the enclosure in the middle, that's usually an off-the-shelf product. There's really not much you can do there. For that one, we just did a manual measurement. There wasn't really much going on there. On the board on the right-hand side, we did the exact same thing, but we did something different with the board on the left-hand side. As you can see from the front side of the board, it's pretty dense, and if you want, you can come and see it right here as well. It's pretty dense. But we had a little bit of a challenge where we needed to add roughly about 40 or 50 components, and we didn't have any room on the board. So they said, hey, Jamie, let's see what we're working with, what kind of real estate we have. Let's go ahead and add some components. And I said, well, it's pretty much physically impossible to add all of those components on the board, so you're not going to get what you want. And then I said, well, maybe we can change some of the components from 0805s to 0402s, and then we can save a little bit of real estate. But then again, I still needed to figure out how much I could expand the board itself. So the red sections that you see right here are all pieces of the board itself that I had to add. I went and I took digital calipers. I did measurements. We didn't have a mechanical designer in-house. I really wish I did. But I was kind of just tasked with get as much room as possible, and we need to fit some of these components on here. So the sections in red are sections that I essentially ended up adding. Now, it was definitely a process, we'll put it that way, and not necessarily a great one. So step one, I had to figure out how much room I had. I took those calipers, I made my dimensions, and then I went into AltiumDesigner and I manually changed the board shape based on the measurements that I took. From there, I just had to make sure, okay, well maybe make sure you don't put any components in any places that are gonna give you any clearance issues, and kind of just cross your fingers and hope for the best. And step two was I had to test it. So I changed the board shape in Altium. I did a one-to-one paper printout because that's my best friend. And everything seemed to make somewhat sense. I was like, okay, well maybe we should take into consideration the PCB board shape as well, because that's something that should be considered, and I have components on each side of the board. So we ordered a FR4, like a Garolite type of material from McMaster Carr. We got that in, and I made sure I ordered an ample amount of excess because I know I was going to screw some of it up. From there, we went ahead and took the DXF. We put the DXF into a DaVinci CNC router, and I had to learn that as well. And it was essentially trial and error until we got it right. So at the end of the day, I was successful, but I had placed a few of the large capacitors too close to the wings that we had added. And you'll be able to see that here when you come and check out the PCB board. So it turns out that it was too close and I had to reposition it. By the time everything else was good as far as the housing, you'll see here that there's multiple components that go into this housing as well too. So everything else was pretty good, but there was a couple components on the side, including that capacitor that was hitting. So I had to change that, and after that we were good to go. But there was a problem, is that everything said and done, it probably took me roughly about 7 business days to measure that board shape, to learn that router, which I never want to do ever again, and make sure that I got the proper cutout of the board. And then we went and got everything made, and we burnt through some prototypes, or just some first run of the boards, because I put a component too close to the edge. So all said and done, I wasted that time. It cost roughly like $3,500 to redo those boards. Didn't get fired, which was good. We have engineering budgets for that, which is kind of good. But all this in all to say is that I don't want you to be better. I don't want you to be like me. I want you to be better than me. At this time, the MCAD CoDesigner tool didn't exist. I didn't have a mechanical designer in-house that could do that board shape for me. So I was really kind of just, going in there kind of green, hoping that I had this board shaping component placement properly. At this time, I also maybe only had 1 year experience with Altium. So I didn't know about the clearance detection. I didn't have the 3D body that I can bring into Altium Designer. So I just want you guys to ask yourself the question if there's a better way of doing things, because I definitely didn't, and you guys can be more efficient than me. So that's what I want to leave you all with today. Anything from a development perspective, please stick around with Nikolai and I. There also will be another talk, I believe it's Friday from 2 to 4, that will kind of cover some of the same stuff we did as well. So if you're interested in kind of looking a little bit more and how that maybe incorporates with Altium 365, I highly suggest you check it out. So for those of you that are sticking around for the next couple days, check it out. I'm available all from now till the end of the day and the next couple days. Thank you so much. We appreciate your feedback. Please, please, please discuss with Nikolai and get your feedback. Yeah. He's like, that's the only thing I want. He's like, I didn't even come here for the presentation. I just want the feedback. So I'll leave you with that. And we're good to stick around. Please ask some more questions. Come check out some of the samples. And I saved you just a little bit of time to maybe get a quick bite or a quick refresher before your next session. So thank you very much. I appreciate your patience, although the tool, thank you.